Answers to your congruent triangles homework. Check your answers. Let me know which ones I need to work. So I was asked about 16 through 21, so let's look at those. Given ABF is congruent to CDE, so what I would start by doing is adding markings to my picture. So A goes with angle C. ABF. Okay. So here's one of the triangles, ABF, where A matches C, CDE. CDE. C is congruent to A, so I'm going to put one arc, one arc. And then we'll do one other angle, and the last one will just fall. B is congruent to D, so B is congruent to D. Oh, so I already know 68, 68. So now I can start to find missing sides of my triangles, or not missing sides, missing angles. 68 plus 85, subtract it from 180, so we have 27. 27 goes with the one arc, so put 27 on the one arc. And E is congruent to F, so we now know angle F. Okay, so we know a few things now. Angle AFB, we just found it, it's 85. Angle CDE, we found it, it's 68. CBF, we'll take a little bit more thought, right? We'll come back to that one. And FAB, 27. Okay, now it's asking for some sides. Side AB. Well, AB is listed first and second. CD is listed first and second, so AB is congruent to CD. CD is 16, therefore AB is 16. AF. Well, let's see. Here's one thing that I'm going to say one time, so I need everyone's attention. Are you watching? Because you're going to ask me this a lot. What does that 11 go to? You see the 11? And I'm covering up the F. Let me move that. There's the F. Okay, I'm going to just take that away. Students will ask me all the time, does that 11, is that for AF or is that for EF? And from now on, when you see a number on a segment like that, it always represents the length from intersection to intersection, from the two closest intersections. So 11, you don't even have to ask the teacher, goes from point F to the very next point you see, to point E, from intersection to intersection. If I wanted to show that it was AF, I would do something like this. If I don't draw something like that, I mean from point to the very next point you see. So EF is 11. FC is 6. Since these triangles are congruent, don't you agree that AE is also 6? Hopefully. And so therefore AF would be 17. Oh, and it says it, okay, well, you know what, it did say it, and I didn't read the directions. But that comes up a lot, and students ask me that all the time, so now we're clear. Oh, the last one is CFB, and that's just a linear pair with 85, right? Those are just a linear pair. Are we okay with that one? So looking at the congruence statement is key to the problem. What else from the homework? Number 30 is also a linear pair. So to get the answer to number 30, ABD, we did one like this in our notes, we would first need to know what ABC is. Since those triangles are congruent, actually we don't even need to know that they're congruent to know that the angles of a triangle add up to 180. So that angle's 50, and so the linear pair of 50 would be 130. Anything else from the homework? So this next slide is an intro into today's lesson. What are we learning and why do we care? So in this situation, we've got a building contractor. I guess that's a girl. I see some long hair. It looks like a girl. And they have just assembled two massive, I like that word, triangular trusses to support the roof of a recreational hall. So a triangular truss, a truss is just what it says it is. It's the support of the roof. So it's just a triangular steel beams that support the roof. Before the crane, before they say, yes, you can go ahead and put those trusses into place, the contractor needs to verify that the two trusses are identical. They need to be congruent. They need to be perfectly the same. Must the contractor measure and compare all 6 parts of both triangles? So do we need to compare the 3 sides to the 3 sides? Do they all need to match? And compare the 3 angles to the 3 angles? That would mean she would have to measure 12 things. So what we need to know is there a shortcut? Because, my goodness, if she measures 12 things every time she has to quality check this, then she might be really inefficient. That might be a bad use of time. And a bad use of time means extra money spent, which does not make the boss very proud. So, is there a shortcut? And surprise, surprise, yes, there's going to be a shortcut. And today is all about learning what is the least we would need to do. Do you ever wonder, like, you're solving a problem and it's like, how could I solve this using the least amount of energy possible, right? That's what we're doing today. We're on the same page. I agree with you. I want to expend the least amount of energy, so today we'll learn how to do that by not doing it. Okay, dun dun dun. These 2 triangles have been charged with a crime. They are accused of being congruent. They're guilty. Well, they're not guilty. They're accused of being congruent. That's the accusation. It's our job to determine if the triangles are guilty or not guilty of being congruent. So we are the judge. Of course, to make our decision, the attorneys are going to present evidence, right? There's got to be evidence. You can't just go off of a whim. Oh, I think they're congruent, guilty. Put them in jail, right? No. You have to have evidence. So the question today is, what sort of evidence do we need? Could we measure one side of one triangle and measure one side of another triangle and say, yep, they're guilty of being congruent because one side matches one side? Guilty or not guilty? If we have one tick mark, that's our evidence, one tick mark. No, right? This triangle could go like this for all we know, and this triangle could go like this for all we know. Are those 2 triangles guilty of being congruent? Absolutely not. So we agree that one side is just not going to do it for us. One side is not enough. Remember, we're trying to find the least amount of work that we can do. What about 2 sides? AC is congruent to DF, AB is congruent to DE. It looks like if I connect those dots, those are going to be congruent. They guilty? Oh, some people are saying yes, some people are saying no. I think we're missing something. Could AC pivot if it wanted to and still be congruent to DF? Could it pivot? Not guilty. Look at that. There's 2 triangles. 2 of the sides are congruent. Look, this one matches, but oh no, the angles are completely different. So those 2 triangles are not guilty. So 2 sides alone, just 2 sides, not enough information. What about 3 sides? No angles, just 3 sides. Is it enough? Do we need those angles? Remember, we're trying to do the least amount of work possible. If all 3 sides are congruent to their corresponding sides, do the angles have any choice? Do they have anywhere to go? Could I pivot AC? What would happen if I pivoted this? I don't even think that's the word, pivoted. Well, if I pivoted that, then to reach BC would get too long. BC wouldn't match FE anymore. So I think that if we have 3 sides matching 3 sides, that we're locked in. The angles are locked in and they can't move. So I'm pretty sure that if 3 sides of one triangle are congruent to 3 sides of another triangle, then they are guilty of being congruent. Slam the gavel. Is that what it's called, the gavel? Slam it. Okay. So we already know that one of the ways you can prove two triangles guilty of being congruent is by knowing all three sides match all three sides. Here are all the different combinations we could have. There are 6 different ways we could compare 3 parts of a triangle to 3 parts of another triangle. Some of these are going to work and some of them are not. We already know that side, 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 we already talked about it, that one's going to work. Now we have to decide which other ones are going to work and which ones just aren't enough information. So take a look at those for a minute. Okay, so remember, we're looking for evidence, but it can't just be any evidence, right? An attorney could present evidence and the judge could say, I'm sorry, that's just not enough inconclusive evidence to show that this person's guilty. I'm going to have to say they're not guilty. So we need evidence, but we need the right kind of evidence. So let's talk about which ones are the right kind of evidence. In your notes, write it down. This one is for sure the right kind of evidence. Side, side, side. Write it down on one of the pieces of evidence that do work. This one works. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Okay, the next one that works is, yes, you said it, it's the sassy postulate. SAS, side, angle, side. If 2 sides in the included angle of a triangle are congruent to 2 sides in the included angle of another, then the triangles are congruent. And we're going to go deeper into what that means right there, because it does mean something, and it is very important, and we'll look closer at that. So that word included is integral to that definition. 2 sides of one triangle in the included angle are congruent to 2 sides of the other triangle in its included angle. It's called side, angle, side. SAS. So we're going to talk about what the word included means because it is important. So I have 2 columns. I've got a yes column and I've got a no column. We're going to look at each pair of triangles and I'm going to drive my little screen shade down and you're going to decide why the yeses are yeses and why the nos are nos. So is everyone making hypotheses of why the yeses are yeses and why the nos are nos? Sizes. No, it actually has nothing to do with the sizes, although I did make the no column, I made them on purpose not congruent. Good, Chloe, that's one way to describe it. The angle is made by the congruent sides. Do you see how where the tick mark meets up with the tick mark, that's where the angle is? Where the tick mark meets up with the tick mark, that's where the angle is. Where the congruent side meets up with the congruent side, that's where the angle is. That happens in all the triangles in the yes column. In the no column, look, congruent side hitting congruent side, oh no, there's no angle there. Congruent side hitting congruent side, oh no, there's no angle there. The angle is not included in the no column. So in the yes column, the angle is what we call include.